Okay, so the agenda: one, why should we start thinking like a hacker? And two, deep dive into how hackers think about exploiting cloud. What I'm going to do in the deep dive is actually show you Department of Justice filings, walk through real world hacks, how they were done, and how you probably should think about them and try to deal with them. And that's going to be the bulk of this. All right, so hackers exploit cloud misconfiguration primarily. In the cloud era, they might break into a server, a compute instance or a container or something, but they're only doing that typically to get access to misconfigured services through API keys, stuff like that. So cloud misconfiguration is by far the number one risk anymore. And many of these misconfigurations, hackers are, the term hacker began its life meaning a clever programmer. Well, hackers are still clever programmers, all right, and they use things that are inobvious to get to your information. So why should we think like them? Answer number one: it's a lot of fun to kind of put on the black hat, even for pretend, and figure out how to exploit systems. It's a lot of fun, and so this should be, I think. And by the way, I'm not just being glib. The reason I say that is things that are fun are things you're going to want to do, and things that you're going to spend time enjoying doing and get good at. I would encourage each of you to do this, and the practical reason is because all we do in security is try to prevent hackers, right? That's our job. And there's all these frameworks for risk and all this highfalutin sounding stuff. At the end of the day, if you don't understand how the hackers are doing this stuff, you're not going to stop them. So it gets to the pith of what we do for a living and in our lives. Now, I'm not a security analyst. I'm a programmer by background. I'm a CEO right now, an entrepreneur, but for a long time, I've been writing code. And a lot of that code has been focused on these security matters, but it's always good to really put the other hat on and kind of come after your own stuff. All right. So a lot of these cloud misconfigurations, and those are things like overly permissive, IAM roles, too long-lived credentials, things like that. A lot of these things, when you look at the traditional kind of compliance and security tools, they're really not equipped to deal with this. So whether it's like NIST 800-53 or SOC 2 or HIPAA or GDPR or ISO 27K, I mean, we support all that stuff in our product. There's great stuff in there, hundreds of controls and warnings and so on. But the hackers are ahead. They are doing things that those kind of compliance standards are not equipped to deal with, and they're not keeping up. And I'm going to walk through real world hacks, probably three, I think we'll have time for today. I'm going to do the Imperva Breach, Uber, and Capital One. Okay. And let me say in advance, none of this is to throw shade at any of those organizations. Capital One's down the road from me. I know a bunch of folks there. They are brilliant. They are excellent at this. Anyone can get breached. Okay. So the reason I'm naming names is because I'm going to use real data, and the names are in there. So I think it's much better to talk about real hacks than to talk about kind of theoretical, fluffy nonsense. Right? We're going to talk about real hacks. Okay. So many advanced cloud misconfigurations they're not considered compliance violations. That means they're not recognized as vulnerabilities by a lot of tools out there. We're different in that regard. They're only apparent often in the full context of an environment. So what you're going to see here is chains that the hackers are employing of mistakes to get to these end results. Very often in the news, there's this huge oversimplification of, oh, it was a public S3 bucket. Very often it wasn't a public S3 bucket. It was an S3 bucket that could be accessed via a set of credentials that were gained some other way, for example. So you have to have that full context. This makes them really easy to overlook. It makes them incredibly common. And all the major breaches I'm aware of are due to misconfiguration of resources in the cloud. All the major cloud breaches I'm aware of. Okay, so with that, let's do a background. Let me choose one here. Let's start with the history of computing. So I'm going to throw an image up on the screen, and the first person to name the device will get a cool t-shirt. Okay, here we go. What is that? Oh, that was quick. I think, Sivia, help me here. It's an Enigma Machine. Was Peter the first?
Peter Collins. Yep, he came up first.
All right, congrats. Boy, that was fast. I used this in a class earlier this week, and no one got it. You guys are good. If you're ever in the DC area, I'm in the DC area. I'm in Maryland. If you're ever out this way, enjoying our extremely humid weather, you should go by the National Cryptologic Museum. It is the museum of the NSA. And that sounds odd, but they have a museum, and they have Enigma machines that you can play with, and they have thinking machines, and the I guess they're called proctors. The people hosting you in the museum are NSA ex-employees, retired employees, and it's an awesome place to go if you're a security geek. Okay, let's do some analysis of some breaches. Okay, let's go back to the browser. I think you're seeing that. Yeah, okay. So I'm going to start with this Imperva breach that occurred. And I want to commend Imperva for just being incredibly good citizens in terms of how they dealt with this. So they had a breach, and this is a blog post from their website. I just have it in like the reading mode of my browser to get rid of all the sidebars and stuff. But they said what happened and what they did about it in detail. And this is really gold if you're trying to understand how hackers breach cloud accounts. So what happened to them now, Imperva is a company that actually makes cloud security products. And as I said earlier, in all these breaches, well, at least in the Imperva and the Capital One breach, they're there, but for the grace of God go I. The Uber breach was very on brand for Uber, and maybe could have been avoided pretty easily. All right, so what happened to Imperva? The TLDR, our investigation identified an unauthorized use of an administrative API key in one of our production AWS accounts in October 2018, which led to an exposure of a database snapshot containing emails and hashed and salted passwords. Okay, so we're going to walk through this in the how it happened and then what they did about it. And I'm going to try to explain every step and how you might want to think about this in terms of thinking like a hacker to point at your own stuff. Okay. So they were porting an application, their cloud WAF, into AWS native services. In this case, they were moving from a manually maintained database into the AWS Relational Database Service, RDS. RDS is awesome, by the way, and highly secure if you do it right. But it has some new kinds of attack surface that folks aren't familiar with if they're just thinking about the data center. So let's talk about the key decisions were made during the evaluation process. Okay, what did they do? And by the way, those key decisions, when taken together, allowed information to be exfiltrated from a database snapshot, not from the database, from a database snapshot, not from the running database. Okay, and taken together. This goes back to the point earlier about a lot of these hacks are require context. You're hacking the system as a whole, not just one service. Okay, and that's what they're saying there, and that's what happened to them. So the errors they made were: one, they created a database snapshot for testing. Okay, don't use production data in your test environments, please. That is an error. If you do, scrub the heck out of it. This is a common mistake, and it can be really hard to truly scrub data to be used in testing. The other comment I would have here is that the advice I just gave you is probably honestly unrealistic. Somewhere in your organization, somebody is probably going to pull production data into a test or a dev environment. So what does that mean? One, you should try to keep people from doing that, but two, they're going to do it, and errors happen. That means you need to secure your test and dev environments as if they were production. Okay. Now, I'm not saying here that you need to have, close off the ability to, add things or whatever. You're probably going to have more restrictions in production, but you should be as worried about hackers getting into dev or test. In my experience, and as I said, this is kind of all I've done for 10 years, dev and test are often the target. Okay, so you really want to employ security tooling, and we're happy to provide that to you, and other vendors are too, and attention to those things. Okay, so they created a database snapshot for testing. Implicit in that is it was a production database snapshot. Two, an internal compute instance that we created was accessible from the outside world, and it contained an AWS API key. Okay, internal here is obviously a misnomer. If the compute instance is accessible from the outside world, it ain't that internal, right? So one of the things that we advise checking for, and our product checks for, is any compute instances or containers that directly have public IP addresses. That's something you should be looking for. But it's really this last phrase where the rubber starts meeting the road. So when the hackers got into that compute instance, what were they looking for? They weren't looking for data. They weren't installing malware. They didn't really care about that compute instance. And this is common in the cloud. Most of your traditional security tools are primarily concerned with protecting networks and hosts on the networks. And most of that is, it's not irrelevant in cloud, but it is not the primary attack surface. The primary attack surface are the cloud APIs. And so this breach happened because that compute instance that was vulnerable contained an API key. Okay, let's talk about this a little bit. So I'm showing you a diagram. This is out of our product. I'm not going to do a product pitch demo here, but I'm just going to show you some things. So here I've got an EC2 instance. We do these automated diagrams for you. And this EC2 instance has here an IAM instance profile, okay, this one's called S3 read write. So that profile is going to contain an API key at any given point in time. Now, this one's configured pretty well. It's using the metadata service to do key rotation, But you gotta wonder, given how this is being described, if that API key were long-lived and actually stored on disk. So one thing you really should not be doing is putting your API keys on disks. It should be through a secrets manager. Again, the metadata service in AWS is good for this, but this is the root of many evils. The storage of API keys, and particularly, by the way, I'm talking about API keys used by your application. So put another way, I should describe that a little bit. So IAM is identity and access management, right? So as Josh, I log into the AWS console using an API key according to my IAM, configuration that allows me access. So that's one kind of access. Those things should also be rotated. But really what I'm talking about here are the API keys that you can find around your infrastructure out running in the environment, right? So like this EC2 instance has API keys associated with it that allow it, S3 read write implies allowing it to, talk to S3, okay? And so if a hacker gets their hands on those keys, well, then they can do anything that compute instance can do. I hope that I explained that okay and that made sense. All right, so 3, this compute instance was compromised, the API key was stolen, and 4, the AWS API key was used to access the snapshot. This is the database snapshot. Now, does anyone know where that snapshot would have been found in AWS? First person that gets the right answer gets a t-shirt too, and then I'll do a fun picture. Does anyone know? Yep, Wally, that's exactly right. So this is a really key difference between cloud and the data center. Okay, in the data center, backups aren't really something that got hacked much, right? Because backups and snapshots and what like were probably being handled through some proprietary system, that was talking to everything on the data floor and going off to, staged media, off to eventually tape or something like this. And if you're a hacker, why? I mean, you don't even know what backup they're using. Oh, I'm sorry. The answer was S3. Wally's answer was S3. So to get to a snapshot, whether it's an RDS database backup or an EC2 disk backup, you're welcome, Paul. Thank you Paul for letting me know I didn't explain it. Those things are stored in S3. Okay, so going back to here, if I have these credentials that do S3 read write, right? I might have those credentials on this EC2 instance. So I don't know, it can like drop photos or something into an S3 bucket. But unless I'm pretty careful, those same credentials are going to allow me to go and look at my database snapshots / backups, and the hackers know that. So you may not think of S3 read permissions as exposing your database, but they may well be. Okay, so this is how when I was talking about chaining things and the hackers being clever, they know where these cracks are. All right, we in Fugue build a lot of that intelligence into our product, but it's constantly evolving, right? It's constantly evolving, and hackers are really clever. All right, we're halfway through. Let's just finish up Imperva, and then we'll give away a shirt, and then we'll go on to Uber. I want to finish up Imperva because they made some really good corrective actions that we can all learn from. Number 1 here, applying tighter security access controls means literally nothing to me, but it sounds good. So kudos, whatever that meant. 2, increasing audit of snapshot access. Yes, please. You should be constantly watching what resources, policies, users, what principals can see your snapshots, because obviously, another way to get API keys is to get access to snapshots to steal the API keys. right? So snapshots are a big deal. So do that auditing. Decommissioning inactive compute instances. I would argue decommission inactive everything. If you're not using something on the cloud, shut it off, because orphaned infrastructure becomes very attractive attack surface for hackers. Okay. Number 4 here, rotating credentials and strengthening our credential management process. I think that this is the single most important thing that's in this list. And as you'll see, almost all these breaches are very much dependent on credentials working over time. So rotating them limits the opportunity for the hackers to exploit you, and strengthening the management process is critical to doing that. 5, they put all internal compute instances behind their VPN. Yeah, all right. I mean, that seems kind of old school to me, but yeah, I would take that to mean don't put public IP addresses on anything that is running an operating system or any of your code. Put things behind gateways. Do not do that. Use the services that are available for secure interaction with those things. Okay, and 6, increasing the frequency of infrastructure scanning. Yeah, I mean, Fugue does infrastructure scanning. We think that this is very important. All right, Hatem asks, what would be the methodology behind rotating the credentials? Okay, good question. I would advise you to leverage credential rotation from the cloud service provider wherever you can, instead of rolling your own. It's hard. It's hard. So the much maligned metadata service will actually, if you're using the metadata service to hand out your IAM credentials, it's going to rotate those, and it's going to do it fairly frequently. So and it's kind of service by service and credential by credential that you have to worry about this stuff. If it's not something where the cloud service provider offers credential rotation, you are going to have to do it yourself or employ some other tooling. And that's where things like secret managers really come in handy. That's its whole own topic that I can't fully delve into today. All right, we're going to do a background, or we're going to do an image. I'm not doing these as backgrounds this time, just doing images. And this one is a, I want to say famous computer, but at least semi-famous computer. I'm old, so it's a famous computer for me. All right, here we go. First one to guess, to say what computer it is, wins a t-shirt. What is that thing? It's not an iMac. No. It's not a mainframe. No. It's definitely not an Apple II, but good guess, Shannon. It's not a Commodore. I'll give you a hint. This is the computer. It's not a VAX. It's not an Amiga. I mean, it's funny. Most of these computers is not a PDP. I have owned. Next Station. No, it is not. This is the computer that Steve Jobs paid Xerox PARC $100,000 to go walk through the Palo Alto Research Center, and he saw this thing, and that's what created the Macintosh. Okay, nobody's getting it. So Andrew got it. This is the Xerox Alto, and it was the first commercial computer. It was a devastating failure commercially, like most awesome things. But this one was the source of the graphic user interface and the mouse. And they also invented at PARC in the late 70s Smalltalk, which was the first true object-oriented programming language. They invented Ethernet. I mean, just so much of modern computing came out of that team. And of course, we all know that Xerox capitalized on that and is a massive computing commercial powerhouse today. All right, let's move on. Actually, let's move on to Uber. Okay, so Uber's been hacked a few times. And apparently, in a fairly consistent manner. This is a DOJ filing. So one thing I would advise you as you're thinking about, thinking like a hacker and learning about hacks, don't really trust the press too much. They try, and I advise often, like newspaper, journalists and so on, and they try, but they oversimplify. They don't really understand. Most of the time, they don't understand this stuff. Like CNET's good at this. Of all people, Wired can be good at this. But, mostly the press gets it wrong. The DOJ filings are much more interesting than the press reports. So if you want to understand a breach, my advice is search for DOJ filings. So this is a DOJ filing for what can happen to you if you do the wrong thing when you get hacked. So in this case, the former chief security officer for Uber was brought up on criminal charges for obstruction of justice for hiding a hack. Okay. Let this be a lesson to all of us. Don't do that. Don't lie about this stuff. Do the right thing, and don't go to jail. So, but what we're interested in is how the hackers hacked it, right? That's what I care about. Let's see. I don't know if in this press release there is much in the way of detail, but in this actual criminal complaint, we get some detail. Okay. So at Sullivan's direction, Uber's security team began an investigation. They were told by hackers, "We have your data, we want money." Okay. And the team realized an unauthorized person or persons had accessed AWS and obtained, among other things, a copy of a database, probably a snapshot, right? Again, the snapshot thing, containing approximately 600,000 driver's license numbers for Uber drivers. That's not good. Based on documents I've reviewed and witnessed, so Sullivan became aware the attackers had access in AWS, and this is where it gets interesting to me, in almost the identical manner of the 2014 attacker had used against Uber. Right, this is in what, 2016, I think? I think this came to light in 2018, but I believe that the breach was in 2016. So 2 years later, somebody does the same hack. Well, what was that hack? The attackers were able to access Uber's source code on GitHub, this time by using stolen credentials. Okay, we're going to drill into this a little bit. Locate an AWS credential, in other words, API keys, and then use that credential to download Uber's data. Okay, so here we've got, again, it's all about context. Oh, shoot, I wasn't even showing, oh, I'm a dummy. Hold on. I thought I was showing my screen. Here, now you're seeing my screen. This is the DOJ filing that I was just blabbing about, and you were seeing my my ugly face rather than this thing. So justice.gov, that's where this data is coming from, and you can see here what I just read to you. Here is the press release with the kind of headline you never want to see about you. All right, so let's talk a little bit about this this breach in terms of the chain of events, the chain of mistakes. So the attackers were able to access Uber's source code on GitHub, this time by using stolen credentials. Well, that suggests it was a private GitHub repo, right? If it were a public repo and they just screwed up and put something out there in public, they wouldn't need stolen credentials to get to it. So they use stolen credentials. Well, we use GitHub at Fugue, and GitHub has pretty robust multi-factor authentication capabilities. So the first thing I question is, and now it's possible to, I mean, you have to be fairly dedicated to do MFA hacks, but it's possible that an MFA hack was done here. It's also possible, I suppose, that somebody's phone was stolen, and then also that particular individual's credentials to log into GitHub were stolen along with their MFA device, but it kind of suggests to me that maybe they didn't have MFA turned on. So word to the wise, make sure wherever you have any kind of SaaS accounts that they are protected with at least multi-factor authentication, and that you're doing frequent rotation. All right, but then this part, this is another really bad mistake. So once they got into GitHub, they found an AWS credential. Well, what in the heck is an AWS credential doing in a GitHub repo? If Uber had been rotating keys and not using long-lived keys that were stored on disk, one, the credential would not be in the GitHub repo, and two, even if it inadvertently were, it would have been rotated out and invalid by the time a hacker breaks into a GitHub repo and steals a credential, right? So this is a sign when you end up with AWS credentials in source code repos or on disk, it is usually a sign that you have very bad practices around key rotation. And the reason is, if you're not using a secrets manager, if you're doing this on disk, well, it makes it a real pain to rotate your credentials, right? So you're probably not going to. And I heard at least one rumor that this particular credential, and a rumor might be a little weak. It might be a little more than a rumor. It was from a pretty good source that this particular credential had been valid for 3 years when it was used. That should not be. That just should not be. Okay, so in the Uber breach, then again, what we're I'll go back to my ugly face. Again, what we're looking at here is an intent to get to API keys, but it's not through hacking a server that was left with a CVE or something like this in the Imperva breach, right? Orphaned infrastructure that had an API key on disk within AWS. This was going to GitHub and finding them in GitHub. Now, there are open source tools. I should have, this is the second thing I've done today, second presentation I've given today, so I didn't quite prep as much as I normally like to, but there are tools out there that will search your GitHub repos for things like AWS credentials and tell you if you have those out there. And Fugue can help with this too. Run those things, find out if you can, because that is a rather bad mistake that can have obviously some pretty dire consequences. All right. I wish I could tell you what happened with the criminal case. I'd have to search for it. Does anyone know? I don't know. I was interested in the hack, not the criminal case, but DOJ filings, they can have detailed info. All right, so let's do
Josh, we did have a question asking if you...
After we do an image, I will talk about the Capital One breach, and then we'll do some more Q&A. All right, we've done 2 computers. Let's do something more LA. All right, name this anime. Yep, I think Rommel was first.
Rommel was first. Yes, he was.
It is Akira. Sylvia, you'll have to figure out who is first. It is Akira. You know, I never know if I'm going to be doing these things and they're going to be too hard and obscure. Like, I used these same ones yesterday and nobody got them. So yeah, if you've not seen Akira, it's absolutely awesome. It's in my opinion, probably the greatest animated movie out of Japan that I'm aware of, and I watch a lot of them. It's 80s. It's a little dated. Bestest movie ever. yes, Rommel. It is awesome, and the manga is really great too. So check out Akira. Making sure my speaker's on. It is okay. Cool. All right, let's go back to serious stuff. All right, back to my web browser. Okay, this time I remember to put it up. Here is another DOJ filing. There's a theme here. In this one, we're talking about, no, Sivia, I wasn't hearing you because my speaker was off, but now my speaker is on. So Sivia, if you have something to say, go for it.
No, I just wanted to say that if you've already guessed a t-shirt and for a t-shirt and you've won, we only send you one t-shirt, so don't guess again. Just leave it for someone else to guess and win a t-shirt.
Thank you, Sivia. Yeah, I've got this speaker plugged in that goes to sleep if it doesn't get sound for a certain amount of time, and that's a really bad idea. Don't do that. It's like a setup for looking like a fool. Okay, for me to look like a fool. So here's another DOJ filing. Seattle tech worker arrested for data theft involving large financial services company. All right, and as is typical, the press release is not super detailed, but the actual complaint is where it gets interesting. So let's go look at the complaint. Here is this complaint. And what's cool about this one is the actual commands used are enumerated. And that is awesome if you're interested in understanding these hacks. Okay, so here's what happened. Capital One determined that the April 21 file was a file on GitHub. This is one of those breaches where the bank never would have known about it except the hacker bragged on social media, and bragged not just on social media but posted the actual files used to breach to breach Capital One on GitHub. Okay, and so the April 21 file, that's what that's referring to. It contained code for 3 commands as well as a list of more than 700 folders or buckets of data. All right. So Capital One determined the first command, when executed, obtained security credentials for an account known as stars-waf-role. That in turn enabled access to certain of Capital One's folders at the cloud computing company, which we know to be AWS. Okay, let's decipher this into reality for a second. So this stars WAF role, all that is, it doesn't mean that a WAF was penetrated. It means that this thing right here, this instance profile association, was to something called star whatever WAF role. It doesn't mean necessarily that a WAF was breached. Okay, so this security credentials, again, they're going for API keys, right, that are contained in that IAM profile association. So and then those in turn enabled access to certain of Capital One's folders at the cloud computing company. So all right, well, that's folders here. They also say buckets. That means S3. So this is a very typical kind of breach where the hacker, and we know from other sources that the hacker used automation to just scan for misconfigured EC2 instances automatically, and saw that one of them was in Capital One's cloud environment. It had a CVE on it or something like this. And she got in here. And from there, she didn't really care about the server. That's the theme. We don't really care about these things. They tend to be ephemeral. They tend to be, using immutable infrastructure patterns. The data is all over here in S3 in this case. And the last 2 were RDS breaches from S3 as snapshots. This one is directly a S3 breach. Now, it says in there 700 folders or buckets of data. Very often, I mean, my little demo environment, S3 buckets are named important records or Sam Porter bridges or whatever. There's goofy human names, but in real life, when you're doing this in an automated way, the bucket names are generally automatically generated and contain things like GUIDs. And the very fact that the hacker got 700 of them and all their data strongly implies, almost certainly means, that list permissions were turned on. List is super dangerous. Get is less dangerous than list. And I'll duel on that one. List is far more dangerous than read. Can we share the network diagram? Yeah. Yeah, and I mean, you can run the free version of our product and get your own network diagram or your own infrastructure too. But yeah, we'll share whatever you like. Absolutely. So list gives you the keys to the kingdom, right? I don't know if I said it in this presentation, but over 90% of hacking is doing discovery. It's learning. And if you deny the ability to do things like list, resources like these, you're not going to be able, as a hacker, to easily exploit them. And so one of the reasons we at Fugue do all this visualization, automated visualization for people, is for you to secure your stuff, you have to know what you have. And you want to deny that knowledge to the hackers. Okay. So, and here we see list buckets command. The second command, they used a list buckets command. The actual command type would have been AWS S3 LS. All right. And that would have brought back a list of those commands. And then the final one, the sync command was used. All right. So sync is interesting here, because sync is not an API endpoint in AWS's S3 service. Sync is a utility command that is built into the AWS command line interface. So we pretty much know that the hacker here was using the AWS CLI, was using these borrowed credentials. We know from social media, she claims that part of the breach was an IAM role assumption. So it's likely that she had to go assume that WAF role, change the role of whatever compute infrastructure she was running from, to then sync those buckets elsewhere. Now, sync does what it sounds like. It looks at two buckets, a source and a destination. And if there's a delta, if there's a difference, it matches them up, right? It syncs them from the source to the destination. Now, if your destination are your own S3 buckets in your own account, and the source are a bank's S3 buckets, it's going to just copy everything, because the delta is going to be everything. So it's going to copy everything. Very easy command to run. It is using under the hood the list bucket permissions. Don't turn that on anything in production. You need to use it when you're designing things, but you should not have, like in where are we? Like this EC2 instance, it shouldn't be able to do lists on these S3 buckets, because if a hacker breaches this, then they can do lists on the S3 buckets. If you need a list of S3 buckets, put it in a database with different credentials. Make their job harder, okay? And by doing things like allowing sync to be used, that job was actually, I would argue, a little too easy. All right, we got a few minutes left. Let me just make sure I'm not forgetting anything that marketing are going to get mad at me about. I don't think so. Let's do another image.
There was also a question back in the back, if there's a way to find that link to that filing. The DOJ.
Yeah, let me put those in the chat. Let me put those in the chat right now. All right, so I'm going to put this to all panelists and attendees. So I'm going to put the press release links to these DOJ filings in here. What you'll find in both cases is at the bottom, there are links to the complaints. Let me go back on screen and show you that. So here's one of the press releases. When you scroll down, and the DOJ filings are all kind of like this, you'll see the attachments. That's where you get the actual PDF complaint. And yeah, they're really instructive to read, I think. All right, let's see, what else are we gonna do? We did that one. All right, we'll do one more. We'll do one more anime since Akira gotten. Provide the Imperva write-up link as well. Yes, I will post that in a second after I do this. After I do this image. All right, first one to get this movie. It's another anime, wins a shirt. There we go. Man. Yeah, Stephen. Yes, Victor, I'm wrapping up. I'm wrapping up. Yeah, Stephen, congratulations. Ghost in the Shell. It's not Scarlett Johansson. Although that movie wasn't as bad as people made it out, but the original anime is amazing. The manga is amazing. It really does an interesting job of looking at the moral quandary of artificial life and so on. But and also just it just drips style. It's so good. Yeah, Ghost in the Shell. So congrats to Stephen. All right. We'll just go back to our slides here. So I'm Josh at fugue.co, not com.co, fugue.co. Feel free to reach out to me. I heard earlier that you folks are involving, students in some of this stuff. And, I love talking to people about computer security and cloud security. This is, oh, that was dumb. This is my passion, and feel free to reach out to me, and I will always respond. All right.